In order to do the exercise, first we need to express which is the random variable. In this case, is the shelf life of a tire used by a truck, which we are going to express it in thousands of kilometers. The exercise tells us that it follows a normal distribution with a mean of 35 and a standard deviation of 4. So the section A of this exercise asks about which is the probability of a tire lasting more than 38,000 kilometers. So in this case, we have to express it such as the probability of X being higher than 38, because it's already expressed in thousands. So if you go to our commander, you can see that this is 0.2266, which this means that we have a probability of 22.66% that a tire will last more than 38,000 kilometers. This means that maybe it's risky to use the tires until 38,000 kilometers, so could be interesting to replace those tires before. We can see in the normal distribution graph, the 38 will be about here, and the probability will be expressed in this area.
Okay, so for the part B of this exercise, it tells us that each time a tire is broken before 32,000 kilometers, there is an extra cost of 10 euros per unit. It has told us that there are 100 trucks with 8 wheels each one, so there are 800 wheels. We have to calculate the probability of the tire, of a tire being lower than 32,000 kilometers, that as we are following a normal distribution, it is perfectly symmetric, and this part will be equal to this part. So it is 0.2266. Now we have to name a new variable, a new random variable. In this case it will be y, that is the number of wheels whose lifespan is under 32,000 kilometers. It follows a binomial distribution. It follows a binomial distribution because it's a Bernoulli experiment done several times. So we have here 800 and 0.2266. Okay, so now that we have the distribution of the variable, we have to calculate the expected value in order to know which is going to be the expected cost and have that savings saved in order to not being in bankrupt. So the expected value of y in this case of a binomial distribution is n times p. In this case will be 800 times 0.2266, that is equal to 181.3 wheels. That, as they are 10 euros each one, we're going to multiply it by 10, so 181.3 times 10 euros is equal to 1,813 euros.